Welcome everybody to our Tech Talk series today. As most of you know, and some of you don't know, is this month is National Cybersecurity Awareness Month. So we invited a speaker to come talk to us today about securing your web applications. So today we have Cory House here to speak to you. Cory is an independent contractor or consultant and Pluralsight author and a React expert. So he's here to talk to you today about securing our web apps. So come on, Cory.
There we go.
Welcome.
Thanks. Hey. Get applause, and I didn't even do anything to deserve it. Like it. Well, good afternoon, everyone. So we're going to talk about building secure web apps, and this is not advanced material. So if you feel like you've already got all this down, then maybe this will be review for some of you. This is what I would consider the fundamentals of building secure web apps. And I think a good way to start this conversation is to think about some of the things that I've heard people say out in the real world. Things like never use query strings or hidden fields or insecure. Encrypt database primary keys for the client. Never store anything in a cookie. You only need HTTPS on login. Never allow users to type a script tag within a form. Or always use post because Git isn't secure. Now, one thing that's interesting about this list of statements is how definitive it is. The nevers and the always. As a programmer, context matters. And when it comes to security, context matters. So if there's one thing that I want to emphasize in my talk today is to think about context and to recognize that speaking in absolutes is unnecessary, that there's some nuance here, and that we have to think about when things apply. So this question of, is something secure, should largely come down to, it depends. I think about Jeff Atwood and his blog. He's got a wonderful post where he talks about an expert. And one thing that an expert does is they ask questions. When an expert comes in the room and you say, should we do X or Y, likely the response from that expert is not going to be do X or do Y. They're going to say, well, tell me about your environment. Tell me about the people on the team. Tell me about what you're doing with the data. Tell me about the performance characteristics that you need. So you start recognizing that the expert needs to know all of this nuance so that they can analyze the context and then provide some advice based on that. Because if it really were as simple as saying nevers and always, then all of this would be a lot easier. So you think about this. Okay, well, I'm creating a simple web form, and a question becomes, so what characters or phrases should I allow or disallow? It surprises me how often I am working with a team, and I see people disallowing certain things as though that's improving security. You can't type these particular characters within your password. Why? What is it about those characters that makes them inherently dangerous in all contexts? I'm using it as a password. Now, sometimes for a password, that's because they want to be able to easily verbalize it, so they want to avoid certain characters. But often it's because someone has an incomplete vision of exactly what security is. So are there any characters that we should absolutely disallow on a form? Can anybody think of some that are commonly listed in this list? What characters are dangerous? And you can yell out. This isn't rhetorical. I really do mean it. I'm okay with y'all yelling answers. So, a single quote. That sounds pretty dangerous. What else? You could start a string with that. What about like a dash dash? Is that a comment in some scenarios? What about angle brackets? That matters in what? In HTML, I could be starting to write markup, or I could be starting to write a JavaScript script tag there. So is that a dangerous character? And the answer to everything we just said is no, a character is not dangerous or is only dangerous in a certain context because it has meaning in different contexts. So when we talk about let's disallow this particular thing, the problem is that security is about context. So we need to analyze where that data is being used to answer whether it is secure or not. So we have to ask, okay, What information are we requesting? What format are we handling? What is the protocol that we're working with? What is our intended use for this data? And that means that we have to think about the different contexts that this data is going to be placed in and how we're going to render that data. So when we talk about context, notice that these are dangerous things. The things over here listed on the right are dangerous in certain contexts. A dash dash is part of a comment if I'm dealing with many RDBMS systems. Whereas in SMTP, one of the most dangerous things is a line break. Because what can I do with a line break if I'm passing over an email? Anybody know? So if I put a line break in a list of emails, that allows me to clarify that I'm specifying another email. So imagine that you give me a field, and you ask for my email address. Well, what if instead of me giving you my email address, I give you a list of 1,000 email addresses delimited with a line break, and I put that into that one input field? Now, are you going to end up sending 1,000 emails to 999 other people that didn't sign up for that? The line break is one of those things that people don't think about as a dangerous character, but in that context, whew, that's a big impact, so it matters. HTML, we know, angle brackets, ampersands, exclamation, these all have a particular semantic for that context. So if I run these in the browser, then it matters. This means that if I'm allowing some user to enter data into a field, and then later I plan to display that data in a browser for other people. A good example of this, imagine that I create a comment box and I allow people to see these comments that have been sent in. Well, if people enter those characters into that comment box and I don't HTML encode them, what will happen? It will actually, the browser will parse that as code, and we will have either a broken display or even worse, perhaps JavaScript running that we didn't run, that we never intended to display. URL as well has its own encoding. So the thing to think about here is making blanket statements about avoiding people being able to enter certain things largely tends to annoy users and doesn't necessarily improve security, because for us to write secure applications, we have to be careful about encoding these special characters based on their certain context. So if I'm going to use these characters down here at the bottom, like an ampersand or a question mark within the URL, how do I do that? Can I put a question mark or an ampersand in the URL and pass that data along? Anyone know how I do that? Y'all are a quiet crew today. I URL encode this data, and then I can pass it along, and I don't have to worry about it being read as a literal instruction. It is instead passed over as data. So I have to handle all my input intelligently. That means if you're handing me an email address, one of the things that I should look for is, did you put a line break within that email address? And if you did, I need to strip it. Now, I don't need to scold you and throw an error and say you're a bad person. I can just quietly take that away, and whoever was trying to hack me is, none the wiser that I have done this. And in fact, in some cases, people decide to not even tell anyone that these things have been resolved. Let somebody go ahead and try it. Values for SQL comes up. I've got to parameterize my SQL to avoid SQL injection. So we'll look at an example of that. If content is user-generated, then I need to HTML encode that content, because I want to make sure that what is displayed is the literal text that they typed and not code that they might have typed. So you think about Stack Overflow. When I go type in my little code example to convey to someone else what's going on, that doesn't impact the way Stack Overflow is styled when I type a little bit of CSS in there. It is encoded in a way that just the text is rendered. Same story with the HTML. So these are 10 security concerns that commonly pop up that we're going to talk about in our time in here. I will not go past 3 o'clock. We may end up a little bit earlier before that, so now you know what you're in for. I am not going to be live coding up here either. I'm going to be talking theory. So we're going to see slides today rather than me trying to code it up. That'll let me cover a little bit more ground. So SQL injection, most people have heard of. Who's heard of SQL injection? Really commonly known, and that's a good thing. Back when I started out in the early 2000s, it was not well understood, and PHP was basically an easy way to expose yourself to the problem. And this is a great example of where characters have context. And so here we can see the single quote has some power here for me to be able to change the way that this works. It's no longer going to return just Bob's data. It's going to return everybody's data because I put this or into the end. So now I have received lots of data instead of one. So one way around this, here's an example using ASP.NET, or I should say C# in this case, where we are parameterizing the queries. And this has been known for quite a while. I would be surprised if this is an ongoing problem here, because most modern frameworks have made this more or less baked in. Back in the early 2000s, this was not such a solved problem, but it is still something to concern yourself with today, that if you are building SQL in a string, that's a dangerous thing to do. Use your library's parameterization tools so that you're not exposed to the risk of somebody changing what your SQL is intended to do. Another way to protect from this, of course, is to use stored procedures, because then those stored procedures provide particular parameters that help structure your SQL in a safe way. So I talked about parameterized queries as an option, stored procedures, and then you can also escape user-supplied input, but really those first two are the ones that are most relevant. And there's also this idea of defense in depth when it comes to security that's just generally important, recognizing that if we can do multiple things that improve security, we're better off. Like we have this here in this building. You recognize that the doors are automatically locked, and also you've got to have a badge, and when you do have a badge, you still got to scan it, and there's going to be other doors within here. And people also social engineering to a degree. If I see somebody piggybacking, if we also as part of that call somebody on that, there's lots of different ways that you can catch people that might be getting past of one of your layers of security, because physically getting into the building isn't necessarily that hard, so you need layering, and that same thing is helpful with security in web apps. Path injection is closely related to this, but this is an easy thing for you to do, where you're thinking, okay, I want the user to be able to request a certain file, and you forget the fact that they could be malicious, and they could put ... // they could maybe move right up out of the file system, and you hadn't thought about the fact that, oh, well, I had never intended that. I thought they just put a file name up here and we'd reference that directory, but now they're moving out of that directory potentially into places where they shouldn't have access. So with this, it's a good idea to use database keys rather than file names, because those keys then give you a finite check where you can say, do you have rights to this particular resource? And also using language libraries, like in .NET, for instance, path.getFilename, so I know that I'm going to get just the file name and not this path that could lead to other problems. Again, with defense in depth here, having a least privilege, making sure that the web server shouldn't be able to reference files that are outside of its needs, so it shouldn't be able to reference these other critical files, and if there are files on the web server that don't need to be served, remove them off that machine altogether, so you've resolved another risk there. So that was issue number one. Issue number two is cross-site scripting. Probably heard of this too. Malicious users can inject JavaScript on the page if their input isn't HTML encoded when it's displayed in the browser. So this is a situation where this would commonly happen. Imagine that you've set up a forum for your customers, and they can go in and they can type comments, they can interact with one another, and when you take those comments, I can type in my message and then I just see it displayed. Now the problem is, when I type a message, all the other people that can see that page are going to see my message. What if I could put some JavaScript into my message and it was actually parsed by the page? That would mean that I could do something like take their cookie and send it to myself, because I could write some JavaScript that says, read the cookie from their browser and then make an HTTP request over here to this other server that I happen to control, and now I have my hands on their session information or some other information that I've pulled from their machine. So this is a matter of a hacker basically running JavaScript on your site. You are hosting their content. You were thinking about it in terms of, I just wanted somebody to type a comment, but in fact, they wrote code. So to make sure that that code doesn't run, we have to properly encode it. So imagine somebody typing this into a user comments field, and you think about storing that in your database. Well, if you end up rendering that on a page without encoding it, it is as though you wrote script whatever right there on the page. So this is very important to HTML encode your output. And this is one of those things that I really like about React in particular. How many in here are writing in React? Lots of people. So in React, if I want to actually display HTML in the browser, if I want to take data and display it there, does anybody know the function and what it's called? Yes, dangerously set enter HTML, which is a great name. I love that it starts with the word dangerously. So you should think twice about your career before you use it. It is a very risky thing to do. And Facebook has done a nice job on that API because you want people to understand, okay, if I think I need to do this, I've got to think twice about it because that means that whatever data I get from the database is going to be presented right here in the browser. And if we happen to have any content in here that has a script tag, that script tag will be evaluated and will be run. So it's a risky thing to do. So this is where sometimes you'll hear, okay, but I want users to be able to style it, put things like a strong tag in here so I can bold this section or write their own bulleted list within a comment. And this is where things like Markdown are useful and why they're useful, because recognize Markdown is really sort of a security play because Markdown is benign. And by letting me convey this in Markdown, I don't have to worry about somebody writing script tags in there because it is a nice, safe subset. Chances are, though, if you're going to allow users to input HTML, that you're probably going to screw it up. So I've referenced chapter 12 of Web Application Hackers Handbook. That's what the WAHH is referring to there. That's a book that I found super useful. It's about this thick, and I read it cover to cover. I loved it. It really is a wonderful book. It came out probably 10 years ago, but they've got a second edition out there too, and most of what's in there is pretty timeless information for web developers. HTML and JavaScript, the standards themselves have been around a long time, and a lot of the exploits remain a risk today. Okay, number 3, broken authentication or session mismanagement here. So the risk here is impersonation and credential theft. And the issue comes from this basic idea. The web is very forgetful. The web is stateless. You could think about every HTTP request that you make to the server. It says, who are you? I don't remember you. I'm not keeping a connection there. So web servers have to have some way to keep that information to know that I am me and you are you over time. And the way that we often do this is through cookies or through JWTs. And yeah, that is an awesome picture. Yeah, I've got to wonder if he did that ironically or was serious, but it's a heck of a facial. So with these, think of them as an identity, as your license. So if I end up stealing your session ID, I'm you. That's all I need to know. And these are long random strings, whether it be a JWT or it be something stored in a cookie, some session ID. If I get that and I send it, then a web browser is likely to think that I'm you. So there's some ways that we can protect these, though. One is to mark them as secure, which means that they can only be transmitted over SSL. That improves life. That improves our security on this. But even more so, marking them HTTP only, which says JavaScript can't touch it. If you've got a cookie and it has a session ID in it, chances are what you want to do is mark it HTTP only. And in that way, even if somebody had found a way to put JavaScript on my page, they found a cross-site scripting attack, They couldn't get their hands on the cookie because JavaScript cannot access that cookie. Now, is that enforced by the browser? Yeah, so the browser automatically sends cookies up. But if you mark a cookie as HTTP only, the browser will not allow JavaScript to read it. So that is enforced by the browser. And you can also go a step further for a defense in depth strategy to say, I'm going to look at the browser fingerprint. So this is an idea of saying, you run certain browser plugins on a very particular version on your OS at this IP address. So there's all this metadata about your request that's going to make your request look a little bit different than my request, even if I have the same session ID. So if all of a sudden I went from running on Mac to Windows, or from running at this IP to this IP, or from running with these plugins to these plugins, that's a strong sign that somebody's session has actually been stolen. So another defense in depth strategy is on your web server, set this up and say, if any of those pieces of metadata change, kill their session, require them to re-authenticate because their session ID has probably been compromised. So it's important to protect cookies. And some things to keep in mind here is do not store sensitive data within that cookie. And I put an asterisk here because the question is, what is sensitive data? Remember I said one of the foundations here is to think in terms of our bedrock is context matters. So when is data sensitive? Like for instance, is it safe for me to put a username into a cookie? I'll wait until at least one person stands up and says yes or no. Oh, that's a great answer. It depends. That's the best answer of all. I agree, it does depend, but what does it depend upon? Yeah, it depends on whether I handle it in a way that is security. What if I'm using that username merely to display the person's username as they navigate from page to page? And I could go in there into my cookie and I could change it to your mom and it would just say your mom everywhere. But that's the only impact is my browser has this dumb joke in there. There's no security risk there. But what if I am using the username in that cookie and reading that on the server to determine who is logged in? Now we have a massive problem because of the context of how that was used. A username and a cookie is not a good authentication mechanism. Instead, we want to have some unpredictable session token so that I can't guess what John's current session ID is. That's why they're really long and randomized. There's your answer. Yes, well done. You get an A. I should have brought chocolate bars. Yeah, gotten the first one. I forgot my candy today. It's a good way to get my kids to eat less too. So using centralized libraries is a great way to avoid these issues too. I also recommend considering well-vetted auth systems. Auth0 and Okta are two popular solutions out there. OpenID Connect, OAuth2 are popular open standards to consider too, but these are also very nuanced to do well. There's a recognition that there's a lot of decisions to make there. You don't simply make this one decision, you still got to configure it. So I do recommend, though, as much as you can, standing on the shoulders of giants, not rolling your own from scratch. And I know here at Cerner, you're likely well beyond this point anyway. Most of you are leaning on lots of your former coworkers that have put in work for years past. So that said, if you did decide to do your own, there are some things to keep in mind here, like salting passwords, requiring long passwords, using a slow hashing algorithm. There are people that will use machines that are filled with video cards because video cards are really good at hashing very quickly. You just throw a big chunk of data and just say, all right, let's see if we can find any matches as we go. So strangely, the slower the hashing algorithm, the better you are. But the problem is, as we know, computing power keeps getting faster, and we keep finding ways to parallelize these things. So what used to be safe is no longer that safe. We're continuing to move on. So I actually had to look out to see what one of the recommended ones is at the time. Argon 2 seems to be a pretty popular one to consider, but options are out there. So remember, that session ID is like my driver's license, and it's like a driver's license, unfortunately, without a picture. So if you happen to hold it, you're now me. So that means that we should never put them in the URL. Anybody know, what's the problem with putting sensitive information in a URL? What's that? Man in the middle, yes. Man in the middle referring to someone else could read that along the way. So what you're getting at is that data comes from some server way over here, but it takes hops along the way, and you think about every hop along the way, somebody's got a server log that now holds that sensitive information in it because it was in the URL. So that's a problem. Another reason is, what about public systems? You can go to the library and look at these URLs, and if there's any sensitive information in that URL, that doesn't go away unless you clear history. So it's not a safe place to keep that information. Another thing we should do is time out session IDs. This is why your bank is very diligent about this. Give somebody a short window where they can get in there, so that way, even if somebody stole my session ID, they've got a very short window before they're going to lose it. Be sure to support logout, and by logout I mean true logout, where it's not merely getting rid of the cookie on my machine, it's sending a call to the server and saying, that session ID, if you see it again, don't honor it anymore. It's like taking the key to my house and saying, all right, we've changed the locks. The moment I log out, the old key that was just working a moment ago no longer works. And of course, use HTTPS, which thankfully, things are much better now. Back in the early 2000s, not so much. So we're using this much more often, and having free HTTPS goes a long way. So what if you're building a login form? Prefer post, of course. Again, you want to do post because you don't want data showing up in the URL. Set autocomplete to off in the username, and this is an easy thing to forget. The reason this is important is, think of the username as a piece of security, as something that should be hidden from people. Imagine I want to know all the usernames for Cerner's clients. Imagine that I had that information. Now I have half of the picture of how to log in for all these people. We don't think about username as sensitive data, but it is, especially as somebody who's trying to hack your clients. The harder that you make it for me to get a list of your usernames, the more secure your system is. Do not limit password complexity. Let me put in a really long username. Let me put in all sorts of different weird characters. Don't worry. Don't think about it. Oh, that's an insecure character or that's a risky character. No, a character is a character. Handle it properly in different contexts, and you can get away with it. Two-factor auth is another way to do defense in depth, which lots of people are using. I will say, I just encourage in general to get two-factor auth for everybody that supports it, not just Gmail, which is really important because it's a skeleton key, but for your bank, for your password keeper that you might have, and so on. I have it for 8 or 9 different services now. The only hassle is when you change phones, you got to set it all up again. That's a bit of a pain. When you're doing password reset, this is an easy thing to get wrong too. Send a link with a random token to the user's email and expire that token over a short period. Do not let that last for very long. Again, you've created a little window where you basically have a proxy for the password. And this is a bit unintuitive, but adding security questions can actually reduce security because those security questions in some cases become a proxy for your password. So if I can either social engineer or go back into history and find out your maiden name or know what street you lived on back when you were younger, I can be you. I can call in. If I can answer those questions, they're going to give me the keys to the kingdom. So security questions are a bit of a risk, strangely enough. I'm not saying that they shouldn't exist, but I am saying choosing those and making sure that your customers are being asked questions that are sufficiently hard for anyone else to social engineer. You'll sometimes see this on Twitter. You ever see people ask questions like this? Like, okay, if you were in a Western, then your name would be the first street that you lived on and your favorite pet's name. And all these people answer that, and you go, what you have just done is answered basically security questions. Why do you think people are posting that on Twitter? Maybe it was an innocent joke that people didn't realize the implications, but think about how much information you share that's hard to find. I've been surprised at seeing this too. I worked at a company that did exactly this. You could go to the password form and you could enter a username and say, hey, I don't remember my password. The moment that I hit, I don't remember my password, and hit submit, they changed the password and emailed it over. Now there's a couple of problems there, one of which is now you've just set the password and sent it over in an email. Hopefully you're going to tell them right away to go change it. The other problem is I just locked somebody else out of their account by just putting their username in. So we want to have a situation where a password that's forgotten should send over a link that then allows somebody to click on it, and at that point now you're choosing to change that password. So this is why I say usernames should be thought of as private data. Here's an example of a site that is poorly put together. I could go in here and just guess usernames all day long, and it's going to tell me the email address of that user. So I am harvesting users and their associated email addresses. Now I could choose to spam them. Now I've also got half the picture of what their username and password combo is. So being very careful about how these things are structured helps avoid people doing this. And you might think, oh, we're safe from this. Well, this can be nuanced too. If there is anything that your system does differently based on whether I put a real email in there versus a unknown email, then it is harvesting. An example of this, if I put bob@gmail.com into a form and it says, sorry, Bob doesn't exist, you've now given me the chance to harvest. You go, why? Well, because you told me Bob didn't exist. Now I'm going to try steve@gmail.com, and you say, an email has been sent to you now, Steve, go check it. Okay, well now I know if I put something in and I get this response, I know that that user's username or email address is registered here, so I can harvest that list. So that's why I say these sorts of little things are easy to get wrong because you don't want to leak any information about state. You'll notice good forms on this will end up saying things like, if that account is registered with us, then you should see an email. If you don't see an email, then contact us. So that way you say the exact same thing whether you got an email that was legit or not. So secret usernames enhance security. If a username isn't recognized, consider just faking it. Like I said, don't say that it wasn't recognized. Say an email has been sent there if we have one. Also, if something smells off, if you're getting a bunch of requests from the same IP address, this is where defense in depth comes in, putting in a CAPTCHA that doesn't allow people to continue to use your password reset form or your comment form. Go ahead and slow them down with a CAPTCHA before you send that over. You can also, of course, consider going out of band, and this might mean that you make them interact with their phone or even come in, send them snail mail. Lots of ways to add another layer of security. I mentioned this earlier, remembering public machines, because public machines will hold on to that data until somebody clears out the cache again. So this is part of the reason that it's important to time out quickly. Somebody can forget to hit log out on their machine, and at which point somebody could come back over and open a tab and potentially still be logged in. Use posts for sensitive data, and don't store sensitive data in cookies. I also have a, every time I do a conference talk, I find myself distracted by bad stock photos. So this one was no different as I'm going, oh, I've got to find some relevant stock photos of hackers. And I just can't, really? You put that on before you were, he does look very sinister. And the hosiery, that, his head looks like a light bulb. I mean, it's straight, or this guy's got to be sweating. Hopefully he's in air conditioning. So hackers don't look like this, and that's really the tricky thing too. As we were talking about security earlier, is defense in depth matters, because if somebody is well dressed and seems to know what they're talking about, they're likely to end up in places that other people might not have let them get into. So Point number 4, insecure direct object reference. So look at these URLs. Imagine that I could pull up a record by putting an ID into there. This happens all the time. This is often how we pass data. You want to deep link to a record, you read that ID from the URL. It's very easy to forget, though, that I could come in and change that URL and I could potentially be requesting any data. So it's obviously important that the API validate this information, because this risk isn't merely about query strings. This is, if there's one thing that you take away from this talk, it is this slide right here. Do not trust the client. And if you think about any data that you get from the client should be suspect, then that is a good mindset. So that means, oh, you asked for this URL with this query string? Who says that you have the right to it? Prove it. Let me look at your session ID. Who are you? All right, based on your session ID, what records am I allowed to give you for this particular data? So there's lots of examples where a client can come in and ignore the business rules that you've set up. Things like validation. You think, okay, I've written client-side validation to make sure that this particular username or password covers our complexity standards. Well, recognize that the moment that I've created any form, people don't have to use that form. Even on server-rendered apps, I have effectively created a public API because I don't have to use the HTML to get there. I can send my own request. This means I can get around things like max length, like the drop-down options that you give me. I can send my own stuff. Remember, the form is for users, but I can go write my own HTTP request using tools like Postman or Burp Suite or even just the Chrome dev tools hacking around in there. This means radio buttons don't really constrain me. The values in cookies don't matter either because I can go into my cookie and I can manipulate the values in that cookie. Sometimes you'll see people try to encrypt the data in the cookie and do those sorts of things. I go, well, no, just what you really need is know who the user is. And that's based on a random session ID that needs to change regularly. So you shouldn't need to do the cookie encryption story there. I could, of course, change the query string. That one's obvious. But you might think of things like, this used to happen more often where people would stuff information in hidden fields and think it's safe there because people can't change a hidden field. Well, that hidden field, when it gets posted back up from the form, yeah, it might be hard for me to change, but I don't have to use the form to submit it. It's ultimately going to be part of the HTTP request, so I can write my own request to get around the system. So think of every form in your system as a public API and recognize that the UI elements that you put on those forms don't really buy you any security at all. It's merely there for user experience. So if the server knows something, then it's very important to confirm that the client is playing by the rules. Every form is a public API, because here we're looking at an HTTP request. This is what actually gets sent when I hit submit, and I can write that up on my own. So as a client, I could go in and set is admin equal to Y if you were storing that in a cookie. It shouldn't be in the cookie. That decision should be held on the server where you hold the keys. I could change prices. Pricing doesn't belong on the client. I could impersonate a user by changing a user ID in a cookie. Shouldn't be storing the user ID. I should be storing that unique session ID in the cookie. I could submit many different times. Even if your form doesn't allow me to do so, I could use a tool like Burp Suite to create my own HTTP requests. I could also create lots of noise too. I could create thousands of submissions even if your form won't allow me to, because I can go around the form. So these are some different examples of how I can bake my own moldy HTTP request. We have to think about the fact that we don't have control over how people are going to hit us. What we do have control over it is how will we choose to respond. So cross-site request forgery is when a hacker forces some other victim's browser to make a certain request. And again, this is one of those places where we have to remember that our site has a public API. So people will often write phishing emails that will get people to go to certain sites where they are performing these techniques. So imagine that you went to one of these sites and my bank had some really poor setup where I could transfer funds using a query string, or I could set my status on Facebook.com using a GET. This is why any kind of data changes shouldn't involve a GET, but these are simple examples here to show what might be accomplished in XSRF. To get around this, you can include random tokens in the request in a hidden field or a query string, and this can be a little bit of work to put together. Some frameworks do this for you, which is nice because you do want to roll these on every request. All right, number 6, security misconfiguration. This is a broad topic, but in general, the issue here comes down to trusting defaults. We don't want to trust the defaults that come with our system. Instead, we want to be specific about how we configure it for our needs, staying up to date, defaulting to disabled rather than enabled. I like systems that start out closed and then you slowly make them open. This is one of the things that I really like about GraphQL, for instance, is that you start out saying, okay, what do I want to expose and how? And then I write code to expose those specific pieces of data rather than like OData, for instance, when it first came out, it was, here's all my data, go ahead and query it, and I have to go close all of the things that I don't want you to do. Change the defaults, that's easy to forget. Remember the principle of least privilege, and this matters in our code in general, of saying, I'm only going to let you know what you need to know to do your job, and each piece of code should also have that. We should avoid displaying error detail to the user as well. This is a fairly easy mistake to make of thinking, I'll go ahead and say, hey, an error occurred, and then I'll put the actual error that happened in there. But that error leaks information about your environment. It says, it may contain even a stack trace in it that says information about potentially your system that can help a hacker go farther. Recognize that a user is not going to be helped by looking at some geeky stack trace or some detailed error message. Being vague is helpful, and instead logging that error, telling them sorry, letting them move on. All right, coming down to the end, number 7, insecure cryptographic storage is an issue. Making sure that you hash and salt your passwords, encrypting social security numbers, credit card numbers, these sorts of things, not allowing the front-end web app to decrypt it. Also, commonly for these sorts of things, it's nice to just not display it to the screen at all or not even send down the data. You think about an SSN, don't send down the whole SSN, send down the last 4 digits and then put some dots in front of that, and that's usually sufficient. If somebody actually needed, what's a situation where somebody needs to read their own SSN? They don't. That shouldn't be displayed on the screen in the same way that if I log into my credit card, I don't need to see the whole credit card number. What I need to see is the last 4 digits so that I know which card I'm looking at. So you'll see that rather deliberately done on sites where you have sensitive data. Don't send it from the client at all. Don't even allow it to be called across. And then keeping keys separate from data as well. So this one's probably the biggest facepalm, and you wouldn't think that it would happen, but it can. Hiding something in the UI does not make it secure. If you have an admin section and you've hidden that admin section by hiding the div via CSS, that is not secure. Goes without saying. An attacker can try random URLs, assuming that just because a URL isn't linked to, it's secure. No, if someone can generate random URLs, they may end up there. So this comes into the category of security by obscurity. Don't rely on obscurity, rely on a system that programmatically enforces these things. So each page should validate whether somebody has rights to do this. Default to deny rather than defaulting to open, and this helps avoid those mistakes. If you start out with the door locked and you open it for certain people, then you're likely to be better off. And if you can, bake that check into the layout or directory structure. So you think about when I go to add a new page, by default, it should require me to be logged in. If your system right now allows me to add a new page and by default it's open to everybody, that is exactly backward. We want to start out secure and then have to make a deliberate effort to make something public. And rather than hard coding checks, having roles for each user on the page is useful. So that way, we also have an ability to audit all that information. This one's quick. Use HTTPS, and I'm pretty confident you are today. When should I use it? Typically always. There's a compromise, but I don't recommend it. Just use it everywhere. Okay, last one. Unvalidated redirects and forwards. This is a phishing issue. You'll sometimes see this where you'll want to redirect from point A to point B, and you'll allow putting a query string up there. Well, if you're going to do redirects at all, it's important to have a whitelist of redirects, or an accept list, if you will, that says, here's the redirects that this particular redirect.jsp will support. And the reason that's important is, what if I can get somebody else to click on a link just because it has a valid URL on the front? Well, it says cerner.com, so it must be a legit URL. But if you've got a page out there that will redirect from a cerner.com URL to anything, then somebody now has a phishing vector, because they can send emails. Even if I hover over the link, I'm going to go, well, yeah, it looks legit. The URL's to a trusted domain, but it's going to immediately pop me over to something else that I might not notice that the URL didn't jive. So ideally, just avoid these anyway, but if you must, then use your own parameters. Do not trust the user-supplied parameters. Put in, for instance, a key that references back to a list of known redirects that you actually allow. Okay, so let's wrap up with a summary. Oh, let's see, does this link work? I just had to show this when I was thinking about the whole finish line thing. Check this guy out. Racing, racing, racing. It's close, it's close, it's close. Wait for it. That's a finish. And you about drop your laptop. Ouch. So there's my finish line video. Totally relevant to security, y'all. See, this is how I get sidetracked as I'm working on talks. I'm like, I gotta find a good video for this. Okay, so let's close with summary here. Handle input based on context. HTML and code user inputs. Do not trust the client. Instead, we need to validate on the server. Remember defense in depth, that there are many different ways to protect from these different issues. So using multiple approaches is helpful. Consider whitelists, accept lists, whatever term you want to use for this, to say, here's the short list of things that we're going to accept. And of course, use HTTPS. Finally, validate your redirects, that they're going places that you actually expect. Now, if you want to go deeper, this is a book that I found really useful, the Web Application Hacker's Handbook. It is not a short read, but it is well written. It has a lot of good examples in it. You can, of course, go out to owasp.org, hackers.org, security.stackexchange. All these are good sites for more on security. If you want to learn more about me, I run my own consultancy. So I specialize in React. I get to travel around helping teams transition to React and also doing training on React and more advanced topics. I'm at reactjsconsulting.com. I'm on Twitter at HouseCore. One of the nicest things you can do, if this talk was at all useful, tweet it out and say so. That's always nice. Otherwise, I've got a few minutes left if anybody has questions. Otherwise, I'll let you go enjoy your day.